Hello students, good afternoon. Welcome to the fourth part of the chapter chemical bonding. In this part we will discuss geometry oblique shape of molecules. So there are various theories are given to describe the shape of the molecule. So among these the valence shell electron pair repulsion theory is simple tool to have an idea of shape of a particular molecule. Okay. So come to the valence shell electron pair repulsion theory. So what are the silent feature of this theory? Number one, the geometry and shape of molecule depends upon the number of valence shell electron pairs. Okay, present on its center atom means at a center atom how many valence electrons are present will be responsible for the shape of the molecule and geometry of the molecule. First point. Second point, the valence shell electron pair repel one another and try to stay in a space as far apart as possible to acquire a state of maximum stability. So as we know that bond pairs and lone pairs create a repulsion between them. So in a molecule these bonds and bond pairs and lone pairs repel to each other and exist uh, at a maximum distance to each other to minimize their repulsion. Third, the repulsive interaction between the lone pair bond pair and bond pair lone pair are different and follow the order. Lone pair repulsion is greater than lone pair bond pair repulsion is greater than bond pair repulsion. Means you can say there will be more repulsion between lone pair and lone pair. Okay, so these are the basic three silent features of this theory. Now come to the shape of the molecules. So the number of valence shell electron pair and shape acquired by the molecules of the types AB and containing only bond pairs. Okay, so first one is AB2 type of molecules. For example, BeF2 and BeCl2. Number of bond pairs 2. So because there are two bond pairs, so they repel to each other and exist in a linear manner with bond angle of 180 degree. Shape will be linear. AB3 type, example BF3 and BCl3. So all three bond repel to each other and exist with each other with the angle of 120 degrees, and this shape is known as the trigonal planar shape. AB4 type molecules, for example CH4 SiH4. So there are four bond pairs and these four bond pairs repel to each other and exist between two far apart with each other with a one bond angle of 109 degree 28 minutes, known as shape is known as tetrahedron. After that, AB5 type, number of bonds 5 and they will repel to each other and form a trigonal bipyramidal shape. Example PCl5 and PCl. This structure can also illustrated as this structure. You can write like this: A, B, 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 this, and B and B. This is known as trigonal bipyramid. There are two types of bond angles will found. Three bond angles of 120 degree and two bond angles of 90 degree. Okay, and AB6 type, that is known as octahedral, example SF6 and TEF6, and all the bond angles of these molecules are 190 degree. You can draw this like this molecule like this: A, B, 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 this, and one be above and one be below. Okay, and all bond angle will be 90 degree. This type of geometry is known as the octahedral geometry. Okay, so these are the some examples of the shape of molecules and their geometry. Okay, now come to the other examples. Molecules containing uh, before it we were watching the compound in which only bond pairs, but now we will watch the compound which have bond pair and lone pair both. So molecules containing both lone pair and bond pairs, for example NH3. So NH3, there are three bond pairs and one lone pairs. So this lone pair will create a repulsion between lone pair and bond pair, which will be greater than bond pair repulsion, due to which the bond angle will decrease and it will come 107 degree. Okay, so because this lone pair will create the repulsion between these bond pairs, and in that condition the shape of this molecule will be trigonal type. Okay, and in water molecule there are two number of lone pair of electron, and these two electron create more repulsion. So now this 10 bond angle will more decrease and come to the 104 degree centigrade, sorry 1 degree 104.5 degree. Okay, so it is known as the V shape or wet shape. Okay, because according to VESPER theory, lone pair repulsion are more than lone pair and bond pair repulsion. Okay, now come to the valence bond theory. So what is the valence bond theory? So Pauling's later theory, the main postulate of this theory are a covalent bond is formed when the when atomic orbitals of two combining atom possesses unpaired electrons of opposite spin. So mutually overlap together, and during the formation of bond, spins of two elements get mutually neutralized. If atomic orbitals have the parallel spin, repulsion will take place and no bond is formed. Okay, so in the Pauling's later theory, they are telling about the formation of the sigma bonds between the orbitals. For example, overlapping of atomic orbitals. So ss orbitals, when one s and 2s orbital will overlap with each other, then there will be one sigma bond is formed, that is sigma single. For example, H and H, there is one single bond is formed, and this single bond is known as sigma bond. Sp overlapping, when s orbital and p orbital will overlap like this, then also a sigma bond is formed. And pv overlapping, so pp overlapping are two types. One is lateral overlapping. So in lateral overlapping there is a sigma bond is formed, but in partial overlapping, this is known as sidewise or partial overlapping. So in this type of overlapping there is a pi bond is formed. Okay, so these are basically types of bonds. Okay, comparison of sigma and pi bonds. So this bond is formed by the axial overlapping of half filled atomic orbitals, but pi bond is formed by the sidewise or lateral overlapping of half filled atomic orbital. Number 2, the sigma molecular orbital is symmetric about the internuclear axis. The pi molecular orbital consists of two charged cloud, one above and the other below of the plane. The sigma molecular orbital does not contain a nodal plane, means there is a node. So in sigma there should be no nodal plane. So sigma molecular orbital does not contain a nodal plane which contains the internuclear axis. The pi molecular orbital contains a nodal plane which contains the intermolecular axis. Okay, this bond is stronger. Sigma bond is stronger due to large overlapping of the atomic number, because in sigma bonding there is good overlapping, but in case of pi bond the overlapping is not so good. So the pi bond will be weaker than relatively covalent sigma bond. Okay, now the atom forming a sigma bond can rotate along the bond axis. The atom forming a pi bond cannot rotate it the along axis. Sigma bond is single bond, so you can rotate this, but in pi bond there is a double bond, so you cannot rotate this. Okay, so these are basic information of bonds. Okay, thank you, have a nice day.